Welcome to the age of artificial intelligence. I am Jose Antonio Menendez, and I will be your instructor for this course. Before we begin, let me introduce myself. My name is Jose Antonio Menendez. Companies announce AI-powered products. Mobile applications include intelligent assistants. Vehicles recognize objects. Banks detect suspicious transactions. Factories predict when machines may fail. Doctors use AI to analyze medical images. However, not every automated system is artificial intelligence, and not every AI system works in the same way. In this chapter, we will examine the meaning of AI, its categories, and how it is already being applied. Artificial intelligence can be described as the ability of a computer system to perform tasks that normally require some form of human intelligence. This includes recognizing faces, understanding language, and predicting demand. A more formal definition describes an AI system as a machine-based system that receives information and infers how to produce outputs. The word infers is critical here. A conventional program follows explicit instructions. An AI system instead identifies patterns within data and uses those patterns to determine an appropriate result. For example, recognizing photographs of dogs. Rather than attempting to write every possible rule, a machine learning system can analyze millions of images and learn the visual patterns associated with the subject. This is a central characteristic of modern AI. It is important to clarify that current AI does not think or experience the world exactly as a human being does. An AI system can produce an intelligent-looking result without possessing human consciousness or life experience. For example, a language model may produce a compassionate message, but it has simply learned linguistic patterns. We should not confuse computational performance with human consciousness. To understand AI, we must distinguish it from traditional software. Traditional software follows explicit instructions. Consider a payroll program. It executes rules exactly as programmed. This is automation, but not AI. Now imagine a system that analyzes years of activity to identify unusual payments representing fraud. A machine learning model studies historical patterns and assigns a risk score. That system uses AI. A traditional inventory system reacts to a fixed threshold. An AI-based system makes a prediction based on multiple changing variables like seasonality, economic activity, and even weather conditions. Traditional software and AI are not enemies. In successful business systems, they work together. AI classifies or predicts information, while traditional software applies business rules and updates databases. Another common source of confusion is the difference between automation, RPA, and AI. Basic automation executes a predefined action, like sending a confirmation email. RPA reproduces repetitive computer interactions. AI becomes valuable when information is variable or unstructured, for example, processing invoices where supplier names or dates appear in different locations. An intelligent system uses computer vision to locate the data. The best enterprise solutions combine all three. AI extracts the data from an invoice, RPA enters it into the operational system, and business rules identify any compliance concerns for human review. The terminology can appear confusing, so let us organize it as a family of concepts. Artificial intelligence is the broadest category, containing several related technologies. Machine learning is a major branch of AI. Deep learning is a specialized form of machine learning. Generative AI includes systems that create new content, and large language models are generative models for language. Machine learning is a method that allows computer systems to learn patterns from data rather than depending exclusively on manually programmed rules. It identifies relationships to estimate future outcomes. Imagine a bank predicting loan defaults. A machine learning algorithm analyzes past examples of income and debt to identify relationships. The same principle applies to retailers predicting purchases or manufacturers predicting failures. Machine learning is commonly divided into three principal approaches: supervised learning, unsupervised learning, and reinforcement learning. Each uses a different method to identify patterns. In supervised learning, the data contains labeled examples. In unsupervised learning, the system receives data without labels and attempts to discover patterns, like segmenting customer groups automatically. In reinforcement learning, an agent learns through interaction with an environment, receiving rewards or penalties. A simple analogy is teaching someone to navigate a maze through trial and error. Deep learning uses structures called artificial neural networks. These are mathematical systems composed of layers of computational units, inspired in a very general sense by biological neurons. Early layers identify basic characteristics like edges and colors. Intermediate layers detect complex structures like eyes or wheels. Later layers combine these patterns to classify a complete object, like a dog. Generative AI adds the capability to create new content. While traditional AI answers questions about categories or future events, generative AI produces written explanations, images, music, and simulations. For example, a user may request a professional email draft, or a designer may request a modern image of a factory. The video you are watching now is an example of how generative AI can support education. A large language model, or LLM, is trained to process language by analyzing enormous amounts of text. A simplified way to understand an LLM is to think of it as a highly advanced prediction system. LLMs do not simply search a database. They generate responses dynamically based on prompts and learned patterns. However, they can produce incorrect information, a phenomenon known as a hallucination. Natural language processing allows computers to work with human language. It can identify what a person is asking, locate relevant information, and prepare an appropriate response for a business. Computer vision allows AI to analyze images and video. In a textile factory, a high-speed camera can detect fabric defects, broken threads, or pattern misalignments, alerting operators before large quantities are produced. Multimodal AI can work with more than one type of information. A physician may combine medical images with clinical notes, or a technician may photograph a machine and describe the problem verbally. AI is also classified by maturity: artificial narrow intelligence, which performs specific tasks, and the theoretical concepts of artificial general intelligence and superintelligence. Today, we live in the age of narrow AI. Creating an AI system follows a life cycle. It begins with a business question, followed by data collection and training. AI is not only a model, it is a complete business and governance process. Artificial intelligence offers extraordinary capabilities, but responsible users must understand its limitations. AI may produce inaccurate information, reflect bias, or fail when conditions differ from the training environment. In our final practical example, we see AI and humans working together. AI handles the scale of identifying subjects and drafting initial responses, while human representatives review sensitive cases. In this chapter, we learned that AI is a broad field combining data, models, and human supervision. It is not magic, but a combination of powerful technical and operational systems. In the next chapter, we will explore how AI developed over time, from its early theoretical foundations to the systems transforming our world today. Thank you for joining me. My name is Jose Antonio Menendez. Continue learning, continue experimenting, continue asking questions, and welcome to the age of artificial intelligence.